Marcos. Hola.
Aaron.
That was Alan. I mean, Alan and
We are recording.
Welcome.
Welcome to fourth period, Algebra 1.
LMS. Alan Koban. Yes.
Keep it down to a little lower, people. Alright, hey, we're going to start our discussion, guys, on compound inequality. New stuff, day one of it. We'll hit the tough stuff tomorrow. But we're going to, everybody say compound inequalities. Get a little enthusiasm, please.
Compound inequality.
Compound inequalities are two inequalities, and, or the word or. Two make a what they call a compound inequalities. Now, the solution, little fingers up in the air like quotes. The solution of and inequalities is where the graphs overlap. You're going to look for the overlap of the graphs. This is called the intersection of the two graphs. Where do those, with and ones, where do those two graphs intersect? That's what you're going to look for. When we do an example, that'll clear up. The solution, and ones. Everybody do this with their thumbs. And ones go like this. Thumbs. These are and. Okay? You're looking for this and that to happen.
Oh, I see.
When we do an example, it'll make sense. The solution of or inequalities is where at least one of the inequalities is true. Its graph is the union of the graphs of the two inequalities. Or ones, guys, generally look like this. Put your thumb out. Or and. And or. Watch what happens here. Pretty cool stuff. Let's do this quickly. All right. The first two, we just have to graph the solution set. Then we're going to write our answers in set notation and interval notation. Okay? Sarah B., read us problem number 1 from left to right. Loud.
X is greater than or equal to -2, and x is less than or equal to 3.
X is greater than or equal to -2, and x is less than or equal to 3. Someone raise their hand and give an x that works there.
Yeah.
Give me an x that is greater than or equal to -2 and less than 3.
Oh.
Scenario 0. That is the solution.
-2.
-2. Does that one work, guys?
Yeah.
Why?
Because it's
Or equal to it, and it's also less than 3. Somebody give me one more number that works there.
3.
I'm just kidding.
Negative what? Say what?
1.
3. Okay. Somebody smart enough to give me a number that does not work there and explain why it does not work.
7.
Briggs,
7.
why does 7 not work?
Well, it's greater than 2, but it's not less than 3.
It's got to work for both of them. And 7 is greater than -2, but it's not less than 3. And the word and means it has to work for both of them. Here's my question. How many numbers are solutions to these?
1, 2, 3, 4, 5,
No.
6. Couldn't 1 work there too?
6.
No.
Yeah, 1 can work too.
1 works too. I didn't write them all down.
8.
No.
1,
4.
Guys, the fractions and the decimals count. Okay? And there's an infinite of numbers in between -2 and 3, believe it or not. There's an infinite amount.
This is or, right?
Right.
Oh.
The numbers outside of
Or
And boom.
and. So watch how this comes into play with these ands. Anyways,
Oh.
when we graph them, you'll see what I'm talking about, Nico. All right, we're going to do the kind of the lazy man's way to graph. We have to put our smaller number first. -2 on the number line would be right there. 3 would be there.
We didn't do this last year.
Okay. Now, I want the numbers that are greater than -2 and less than or equal to 3. And I want so on the -2, we're going to put a solid circle because it could equal -2. And on the 3, we're going to put a solid circle because it could equal 3. And then, everybody put your hands up in the air. Where's the overlap of these two things? In the middle. Okay? Does this make sense now or no? Nico, does this make sense now?
This way, we put it on the outside.
Oh.
This way would be in
Or.
or. Because it's this or that. As long as one of
So
them's
since
true.
it's and, they're going through the middle.
Right. Banana. Wait, let's put it in set notation now. Now, do you guys see an infinite amount of numbers in between here now?
Yeah.
With all the fractions and decimals? I mean, we can make up anything.
But they end somewhere.
No, they don't. There's an infinite amount of them.
Yeah, they do. They end at 3. Negative 2
No, because you could do
goes in.
But just the number, I agree that it doesn't go on to infinity, but in between negative 2 and 3, Al, there's an unlimited number of
Because you can do
numbers.
There are.
Yes.
There are. Correct.
There are. All right.
Yeah,
Two.
Wait, here's how we're gonna write this though. We're gonna set notation. Everybody put their little braces. All x such that. Put the smallest number first. It's gonna come into play. I'm gonna put one in there. But when it's an and one, we're gonna write it in set notation this way. Negative 2 is less than or equal to x. Is that the same thing as x is greater than or equal to negative 2?
No.
Yes. No, it is. Look, I just flipped it around. If I flip it around, the inequality sign flips.
So do we have
Which
to
is-
flip it around?
Less than or equal to 3. And I just wrote that what they call compoundly.
Oh, that makes sense.
That's a compound inequality. And guys, think about this for a second. Did I shade in the stuff in between negative 2 and 3? Isn't x in between negative 2 and 3?
Yeah.
It's the same thing. Okay? Now, let's see if you guys can write the interval notation. Right? We gotta write an interval notation. Bracket,
Hold on. Didn't you? Oh, wait, no.
right?
I'm wrong. Yeah, that makes sense.
It's gonna make sense once we do a
Because
couple of
there's
these.
an underline.
Bracket, what's gonna be the first number in our interval notation?
Negative 10.
Comma. 3.
No. Is
No, no,
less than.
no.
Infinity.
Remember, in interval notation, there's no inequality signs. It's just numbers. No.
Comma
Bracket.
infinity.
Why is it a bracket at the end?
Oh, there's no infinity and it's.
Guys, why is there no infinity in it?
Because there's it ends.
It goes
Two
from one
dots.
point to the next.
It doesn't go to infinity or negative infinity. It's just the junk in the middle. It's one of these. So, interval notation would be bracket negative 2, comma 3. And a set notation would be all x such that negative 2 is less than or equal to x, which is less than or equal to 3. That's the tricky one to get. Once we do a couple examples, though, you'll get it.
Wait, Mr. Peter.
Cuban question.
So if there are no lines, like if it's not or equal to, is it just parentheses?
Yes. Excellent question. Nico.
So the signs before and after the X are always the same?
Yes. And you can only write and ones this way. Let's catch on to that. You can only write and problems with the x in the middle. And the inequality signs always go to the left. Always. You'll never see a compound written one where the inequality signs point that way. They always go that way. When we do a couple, you'll catch on to it. All right, now, x is less than or equal to negative 2, or x is greater than or equal to 3. Is that an and or an or problem?
Or.
How do you know it's an or?
Because it says or.
Because it says or. Some kids don't even know if it's an and or an or problem. Really? That's an or. So, somebody give me an x that's less than or equal to negative 2, or greater than 3. Make it up off the top of your head. Olson.
Wait.
Hi, dear.
X is 10.
Could x be 10 here, guys? Yes or no?
No.
No.
Why not?
It could be 3.
It's not.
Well, it
less-
can be greater than negative 2, so yes, it can.
Oh, that's what I'm saying.
It means
Ten-
greater or
ten-
equal to 10.
Wait,
Only
the
is
only
negative.
numbers are negative 2 and 3.
No, not at all.
It could be
10
zero.
guys, the word or
Four.
means,
Four.
as long as one of the things are true, it's all true.
I get it.
So, 10, yes or no?
Yeah.
Yes, because it's greater than 3.
Also, if it's an and problem, both of them have to work out. But if it's an or,
And
only
only
number
number
one.
one.
If you can remember that, you're a genius, Olson. Seriously. That was well said.
Alex, that
Practice your high fives, guys.
deserves Julio.
Yeah, it's supposed to be like.
Okay, the person that gets hurt, let's move
Yours
on.
back is your
All right, somebody give me a negative x that works there. Why does negative 5 work? Because it works for one of them. Good answer, Briggs. Now, don't blurt it out, but somebody raise your hand and give me an x that does not work here.
Lego.
Raise your hand. What value of x does not satisfy the conditions of less than or equal to -2, or greater than or equal to 3? Henry,
-1.
why?
Because it's
0.
Greater.
Because it doesn't satisfy either part, right? Doesn't work. So, watch how we graph
But
this.
it is less than 3.
But we want greater than or equal to 3.
What about the -2?
So, is -1 less than or equal to -2?
Yes.
No, it's not.
That's what I meant.
No.
Doesn't work for the first case. Is -1 greater than or equal to 3? No, it doesn't. So this -1 does not work. So I have this stuff in the middle. So ors, remember, ors go like this. Hands up in the air. Ands, ors.
We should connect the ands.
Watch.
Yeah, because and is like a word in the middle, or is like infinity, or that.
Go ahead, Sean. I'm
So,
listening.
on the lines, don't we just write the numbers that they give you?
Oh. Yeah, that's what I did. -2 and 3.
That's all you have to do.
Yeah, that's all you have to do.
Bucks and or
wait,
ors.
so,
That should be his middle name.
Look how the thumbs now, guys. Look at the first one, the green one. It's an and in the middle, ors outside.
Ooh.
Okay? Let's try to write this in set notation though. Braces, all x, such that x is less than or equal to -2, or x is greater than or equal to 3. Go ahead, Aaron.
Can there ever be an open circle?
Yes, if there's no line underneath it. Remember, if it's just, remember the little line underneath the inequality sign?
Yeah.
If it's just less than or just greater than, not the or equal to part, then it would be an open circle. All right, now the set notation, interval notation with this stuff's tricky.
Let me do.
Where does the blue, the left start?
Negative infinity.
Negative infinity.
So parentheses negative.
Oh, comma, infinity.
No, because it doesn't include the stuff in the middle.
Between negative
So
0.
comma 3, comma
0.
No,
Negative 2.
-2.
That's it?
That's half of
Ends
it.
at -2.
Only do 2 of them.
You gotta
and
do
then
2 of them,
then
but
do-
you gotta put a U in between them.
Okay.
Trust me on this.
You gotta-
Guess what the U stands for?
Undefined.
We already mentioned it today.
Union.
The union of +3 to infinity. That is interval
This is
notation.
so confusing.
It's tricky. I'm glad you're writing it down though, Al.
I am.
That's so weird. I'm not feeling this.
You're not going to fail the test. Do not be negative Nelly.
So,
Be optimistic.
Yes.
Nelly
There you
is.
go. I like
Sweaty
that.
Sally.
He's choking.
All right.
Sweaty Sally.
Those are just graphs. Let's solve a couple of these now. Okay. Chupinski, read us problem number 3 from left to right. Just read it.
-6 is less than 3x minus
I think so.
is less than
That is written compoundly, and they're going left. Okay, they will always go to the left, and this is always an and problem. I don't think they will write any ors where everything's connected like this. Okay, and to solve this one, it's not bad. As long as you don't have any variables on the outsides. Notice, -6 and 12 on the outsides, there's no variables there, just the variables in the middle. We're going to solve for x here. And we're going to do the same thing to all 3 sides. It's new. Remember before we always did the same thing to both sides, right? That thing has 3 sides now.
Yeah. 6, 3x minus 9, and then 12.
The left, center, and the middle. And what's our goal, guys, to solve for what?
And x.
Where's x at?
Middle.
Yeah, I'm failing this.
We're going to move on. Seriously.
It's actually really hard.
It is really hard. So, everybody look at the middle. We're going to get x by itself. What would we do to all 3 sides to start to get x by itself? Not divide by 3. That would be the second thing.
Divide by
It
negative.
has to be a negative.
Oh,
Plus
6.
9.
Let's add 9. Everybody always wants to add 6. No, the 6 is good. We're trying to get the x by itself. So let's add 9 to all 3 sides. Now look how I did that. You do that.
Well, could you subtract 3x from...
Nope, not. Let's add 9. Everybody do that. What does the compound inequality now say from left to right? So now I'll take a risk.
Okay, 3 is less than 3x, which is
Nice. You did it right. And again, our goal is to do what?
Solve for x.
Get x by itself.
Divide by 3.
Can't that be
I can't add it.
integral notation, or is that like set notation?
No, but it's going to be when we get the answer. Because we don't have the answer yet. We got to get x by itself, Henry. Aaron, what do we do to all three sides now to get x by itself? Let's divide
I know
all.
it would be
Divide all three sides by 3.
1 is less than 3.
X
and is less
seven.
than 7.
You got to say all the inequality signs, though, Henry.
1 is less than x and less than
1 is
So-
less than x,
Okay,
is less than
X
7.
is in between 1 and 7. All the solutions are in between 1 and 7. This is thumbs up in the air. This is an and. Okay? So to graph it, I'm going to put a 1 to the left and a 7 to the right. And then over to Briggs, open or close circles. Then look at the inequality signs.
Yeah, open.
These are both open circles. And we want, read it from the outside, we want x to be greater than 1 and x to be less than 7. So I'm gonna graph the stuff in the middle. All those x's work. Notice Henry kind of hinted at how this is going to work. You can put your brace in front of all this and write x such that you got your answer already.
Hey.
Okay?
Works
You
out.
can do that. Can anybody put it into interval notation?
Oh, I'll try.
Oh.
Oh, I try.
Try it. Quit living, take a risk.
Would it be bracket 1?
I don't think it's going to be brackets. There's no or equal to. If it's just less than,
Oh, so parentheses.
so parentheses,
Why?
Why?
1.
Because there's no line.
There's no line underneath the
Parentheses.
and then what?
Parentheses.
Parentheses. Guys, what stinks about interval notation, for these kind, it looks like a point.
Yeah.
1 comma 7. But it's not a point. It's 1 to 7, not including 1 and 7 because of the parentheses. This is tricky.
Why is it a
Why is it parentheses? Okay,
And
remember
should move the
brackets
test
go around them when there's or equal to.
We should just do a test on
The line
this.
underneath it.
Just this.
Right? Oh, we're going to do the special cases tomorrow. Wait till the special cases.
Are they harder?
Oh, yeah.
We should. Why?
Number 4. And or.
We should just not.
Or.
We should move the
Everybody
test
solve both ors. Go.
Like 3 years.
Also, don't say dumb things.
Do we solve?
You have to get X on
Flippy on the
Yes.
second one.
Flippy on the second one.
Oh yeah.
Lapa.
Don't forget to flip your inequality sign when you multiply or divide both sides by a negative. Okay? Put your thumbs how this one probably goes.
We know it goes that way.
Oh my
Sidaro.
gosh, Sidaro.
I don't understand.
And
What?
or.
Oh.
And
Zero.
usually. Ah, good. Hey, tomorrow stuff. Could anything ever do this?
Yeah.
Oh god.
Yeah.
Come on,
That's
Could
come on.
anything ever do this?
That's like
Could
a
it do
problem.
this?
No, like the 3D graph, like this.
We're not doing 3D graphs.
Like this?
Good idea, though. All right, let's graph this thing.
Alex.
And we'll write it in set notation. So remember, -3 has to go to the left, and +3 has to be on the right. Briggs, open or close circles?
Close.
Close circles, both of them. You'll see that one of them we have one of each. And then it's less than or equal to -3. So I'm going to go to the left, and it's greater than or equal to +3. So I'm going to go greater than. And does that look like the or, guys?
Do we have to make numbers?
If one of them.
Yeah.
If one of them is
These numbers have to be here.
No, just numbers.
And now we're going to do it in set notation.
Like how we were making up numbers that fit for it.
Oh, no, you don't have to make up numbers. Your graph, I was just trying to explain what possible solutions are, Nico. The graph shows you all the solutions. And your set notation, x greater than or equal to 3, or x less than
Can
or
I
equal
come up there and write the interval?
to -3. I would
Wait,
love for
no,
you to
wait,
go
I actually got that right.
Oh, no, it
Can I tell you it?
Yes.
So if one of them isn't like less than or equal to, it's just like less than. Then one would be open, one would be closed.
Correct, and we will have one of those in a minute.
I don't think we have to do.
No, they don't have to both be the same. It could be one open and one closed. Good thinking, though. So now,
Set notification, I thought we had to do lower numbers first.
You could, yes. You totally could go x less than or equal to -3 or x greater than or equal to 3. Same thing, Sean, I would not take off if you didn't do it. Your answer is actually better than mine. Good job, Sean. McNulty, give me an interval notation.
Parentheses, negative infinity, comma, -3, bracket.
Say union.
Union, bracket, 3, comma, infinity, parentheses.
Beautiful. You were the man, dude.
Is it negative infinity because
Oh, excuse me.
is it
Should
negative
have hit pause on that one.
infinity because
Excuse me.
there's a line under?
What was your question?
Why was it negative infinity?
Because it starts at negative infinity and goes to -3.
Also, all or problems are gonna be like that.
Yes. Or ones are going to have infinity involved somehow. All right, jump to the back. We don't have much time, guys. Seriously, we got 10 minutes. All right, number 3 and 4, we're going to skip them for time reasons, but everybody put your arms up what number 3 probably does. It's a norm. Goes like this. How's number 4 probably go? It's going to be like that.
Or maybe.
Okay? Well, those are the special cases tomorrow. All right, let's do 5 though, because 5's tricky. All right, something weird happens, guys, when there's variables all over the place. Not just in the middle. You have to do this. Everybody take a little pencil and draw a box from the beginning past the first inequality sign all the way to the second inequality sign and then stop right before that. So like right after your 6, draw a box. That's one problem. Then start after your first one and draw a box like that. So it's 2 problems. Oh, who knows if this is an and or an or problem?
Oh, I do.
It's an and problem. Whenever they write them all together, that's definitely an and problem. So, but you have to break it up the way I just boxed things. 3m plus 2 is less than 5m minus 6. There's the first box. And, Henry, how do you write the second one?
5m minus 6 is less than or equal to 2m plus 9.
Nice. These get long. We should have given you guys more paper. Ouch. All right. Solve both those individually, guys. I bet it works out something like this. Go. Do it. I'm going to kill 2 birds with 1 stone.
Flippy.
Flippy.
You can get arrested for that.
Anybody else get m's greater than 4?
Yeah.
Did I do that right?
Wait, M is greater than 4. What? No.
What'd you get, Al?
M is greater than 2.
You know how to divide?
Yeah.
Did you get negative 2m is less than negative 8?
No.
What'd you get?
Negative 2m is less than negative 4.
Oh, did you subtract 2 from both sides?
How'd I get negative? I subtracted 2.
You gotta subtract 2 from both sides. Show your work. Fix it. All right, second one. Oh, and let's kill 2 birds with 1 stone
M is
here.
less than or equal to 5.
Is that right?
Confirm.
3m is less than or equal to 15.
Get him.
Yeah, man. M.
Feels like they
What'd you
like-
say, Olson? M is what?
It's like they
less
shut
than or
my
equal to
mouth
5.
so I can't
Sweet.
talk.
And Alex, is this Olson? Is this an and or an or?
This is an and.
It's an and. It's going to go like this, in between 4 and 5, okay? But one of them is an open circle, and one of them is a closed circle. So, graph those over here on the graph. 4, 5, open, closed, and then are we going to go outside of those?
No.
Or are we going to go in the inside stop?
Outside.
Oh, yeah.
Inside, it's an and. So we're going to go in between 4 and 5.
Do you have to like draw the squigglies?
Yeah. Yeah. As long as it's clearly shaded in, I'm happy with that. Okay? All right. Let's do the set notation real quick. All M such that the smaller number first, 4 is less than m, which is less than 5, and your braces. Remember all the m that's in between 4 and 5.
I know you don't want us to write it this way, but could you write all m such that m is greater than 4 and
M is less than,
m is
less than or equal to.
Wait, you have to put less than or equal to.
Five.
I'm
Yeah,
5.
rather than
Thank
that.
you. Didn't catch that. Yes, Kevin. Yes, you could answer it that way. A little bit longer, but that's fine. Okay, but write it in interval
I
notation.
think I can.
No,
Yes,
Who
I
can write it in
can.
interval notation?
Mr. P, let me come up to the board and do it.
No, that's okay. We don't have
we
time.
gave you
Nico.
rubber bands and it's
4
hard to move
or
them out 'cause
parentheses 4, comma, 5 bracket.
You were the man, dude. 4, parentheses, 4, comma, 5, bracket.
This is so hard.
All right, skip 5. You might have a word problem where it says all prices are between $3.50 and $6 inclusively. Okay? What's the word inclusively mean?
In between.
What word is kind of like by inclusively?
Included.
Included. So that means the 3.5 and the 6 are included, means it'd be filled in circles.
Or brackets.
Okay? Or brackets. Very
Or-
good.
It's an or.
No, I think it's an and.
Which is
This word and would probably give it away.
What?
All right.
You said.
I totally screwed up, guys, on the next part because I forgot to write. My job was to write in craft stuff, and you were to write the inequality. So you have to write this down right now, and when you see it in the book, it'll be written down for you. Because kids were like, we have to make up our own problems? No. I forgot to write these in there. So everybody do this.
Who said that?
Put a 0 and a 4 on the first one. Madeline B, you want open or closed circles? You decide.
Open.
one of them.
Closed. Everybody put closed circles. And Madeline, do you want it to be an and or an or? Your choice.
And.
Don't be an and. She wants an and. Which way would I graph it if it's an and? In between. Okay. So you were gonna see. You will see that. I was supposed to write that in, and I didn't. My bad. Can anybody write the inequality for that?
Yeah,
See, it's easy. You guys would love a ton of these problems.
X is
Start with the variable x.
X is
Oh, that's so
greater
Greater
than
than or
0.
equal to
Wait. It's got a full in
Greater
circle.
than or equal to 0. Or X is less than or equal. And
It's
X
an
is less than
and.
or equal to 4. Yay.
Can anybody write compoundly?
I think I can.
How do you know it's less than?
Oh. Does it work?
It's less than or equal to 4, greater than or equal to 0, and he knew it was an and because it does the.
Oh, you forgot the line again.
I can write it compound.
Thank you. Let's hear it, McNulty.
Okay, 0 is greater than or equal to x.
I think less than or equal to.
Oh yeah.
So I'm gonna
I
switch it
wrote
around.
the wrong way. Sorry.
This is the best way to write it, guys. It's always going to be less than or equal to for all your inequality signs. Yeah, but we don't. For these ones, you guys just have to write them once. You don't have to write them in set notation and interval notation. So that's now. Let's do A. We're going to do one or one. Okay. Over here, let's put -8 and -3. Let's do one of each. Do an open circle on the -8 going to the left, and put a closed circle on the -3 going to the right.
No.
It's an or.
How do you know it's an or?
That is
Because it goes out.
Somebody write it.
Oh,
Choose your
yeah.
favorite variable. Use the word or. Be smart with your inequality signs. Come on, give it a shot.
X is less than -8 or X is greater than or equal to -3.
Genius, dude.
Yeah, I do.
You will have some of those. They will be giving you the graphs, guys. I forgot
Those are
to
the easy
write them in there.
ones.
Okay? So we will try to get through the rest of these if we have time tomorrow, but we're going to do our special cases tomorrow. Everybody sign off, say goodnight.
Good
Alabama.